Alright, it's time to get down to business. We're going to do some calculus today. The first, major topic, and this is actually the basic topic which all of calculus at some level boils down to, be it the derivative or even other things from calculus. The common notion behind all of that is limits. Alright, so we're going to talk about limits. Limits are a very basic thing and actually pretty intuitive. Not so hard to figure out the limits of various things. Actually, I thought before we do that, I want to talk just a little bit about functions in general. So functions and limits is really what I want to go over this time. Hopefully what I say about functions is going to be mostly review. Mostly I just want to make sure everybody's on the same page about how we're going to write things, how we're going to, what kind of language we use, how we're going to talk about certain things. Okay, so let's talk about functions, right? Functions typically you either have an equation for them or you look at a graph. Today most of what I want to do is going to be about graphs. So there. All right, this is my function f of x. I'm not going to give you an equation for this. I just made up the curve. It doesn't necessarily obey any kind of equation. All right. Typical things that you would want to say about this graph, something like, for example, in this case, f of 2. What does f of 2 mean? It means what is the y value that you see when you look on the graph where x equals 2. So you go, all right, x equal 2, you go over here, 1, 2, that's x equal 2. The y value there is 0. Okay, so that's what I mean when I say f of 2 equals 0. This is what I meant by, I hope this is stuff that everybody already knows, so we're just going to make sure we're all on the same page here. Okay, what else can we say? What about f of 3? That would mean you go at x equals 3 and look at the y value there. I tried to make it so that f of 3 lines up here. So f of 3 equals 1. How about f of 0? That means you look at x equals 0 and find the y value there. That would be 2. All right, etc. Okay. That's all I'm saying, right? You can do any of those points. I tried to make it line up. All right. So that's what f of f of whatever means. Pretty straightforward. Okay. All right, that picture that I just had was a nice sort of nice looking graph. Sometimes the graphs can be a little bit weirder. Like sometimes you can see sort of jumpy jumps in your graph, right? So I'm referring to something like, let's say you have a function that kind of goes like this, but then at this point something weird happens and it just suddenly jumps up there and becomes this. Let's say this is f of x, all right? Typically when you have an function which is given by an equation, most equations that you write down don't have this kind of jumpy behavior, but there are lots of the times when you want to use functions which behave in this way, all right? One thing that you'll see here, actually I haven't been very specific. What exactly is f of 2 in this case? What's the y value when x equals 2? Well, the answer would be, well, I don't know actually. Is it that or that? Is it the 1 or the 2? And the way to be specific about that on our graphs, when we draw these pictures, I'm usually going to draw something like this. I draw sort of a fat circle here and an empty circle here. That means f of 2 is 1 rather than up here, which is 2. So the fat circle, the empty circle, that means you do this one here, not here, right? The empty circle means the value is not there, it is here. All right, so that's what this full circle, empty circle means. Sounds like the kids are home. All right, I'm back. You can see my my daughter Mary is also an expert in the backwards writing. Sometimes you'll see 2 empty circles. That means the value is neither of those places. Maybe it's like this, right? Maybe it's something like this, okay? In that case, where's the value? Not there, not there, it's down here. So in that case, the y value would be 0, right? f of 2 equals 0. Okay, sometimes you'll see no value at all. Here's one of those. Maybe it's just all empty circles, right? Maybe it's like one of these, and nothing else. Let's say this is x equal 2 again, right? In this case, you would say f of 2 does not exist, because there is no y value where x is 2. All you see is a bunch of empty locations with no values, right? And there is no filled in value anywhere. So f of 2 does not exist. Usually I'm going to write this, f of 2 DNE does not exist is what that stands for. Alright, so the empty circle, the filled in circle. It can be, it's not really that confusing, I just want to make sure everybody knows what I'm talking about. Alright, let's talk about limits now. Okay, so how do you find the actual function value? You just look on the curve where the x value is, what's the y value, okay? A conceptually similar, but not exactly the same question is about limits, okay? Limits, we're going to write, the idea of a limit, the limit is the limit of a function is where the y values approach as we get close to a particular x value. That's what I want to say here, all right? What's the difference between this and what I was just talking about? Well, what I was just talking about is what is actually the value at a particular point, all right? And this sounds similar, but it's not exactly the same. This is what do the values get close to as you get close to a particular point. Not what is the value right at the point, but what are the values as you get close to that point, okay? Should sound almost the same, but it's not quite. Usually on an ordinary looking picture, this thing, these values actually are the same as what I was just talking about. Let's for instance look at this one. What is f of negative 1? The answer is you look at the x value, the y value is 2. All right. I could also ask you, what are the y values getting close to when the x values are getting close to negative 1? That would mean if I look at x values like in this region here, where are the y values? And the answer is they are still around 2, right? When the x values are near negative 1, the y values are near 2, okay? The way you write that is like this. Lim x goes to minus 1, f of x equals also 2, okay? What this means, and we say the limit as x approaches minus 1 of f of x equal 2. And what that means is when the x values are close to negative 1, the y values are close to 2. Which is also true, all right? Lest you think that these two statements are the same, they're actually not the same as each other, although they are in the case of this graph here. Here's an example where the limit is not the same as the actual value of the function. This can happen when you have some kind of a jumpity jump. Okay, what about, here's an example where the two things are actually kind of different. Let's consider something like this. Say like that, but then it also has a point. Filled in down here, okay? Empty circle up here, filled in circle down here. This is y equals 1 up there, all right? Let's talk again about what is f of, I'm considering this point here as that's kind of the interesting point. It's the point where some weird business is going on, right? What is f of negative 1? Maybe I'll make this a little fatter than 1's. What is f of negative 1 here? That means when you look at x equal negative 1, what's the y value? And the answer is, the y value is down here, negative 2. Right? I hope that makes us a lot of sense. Okay. What about the limit though? Here you'll see the limit is actually not equal to negative 2. Limit as x approaches negative 1, f of x. What is that? What that means is when the x is nearby this point, what is the y close to? Well, when the x is actually straight up at this point, you use the filled in dot, all right? But all the nearby points are going to use the curve because that's what the function, the points on the curve describe where the function is going. So as you approach this point x here, you follow the points along the curve and you get this y value, right? All the points, if you look along the curve, all the points nearby have y value 2, okay? Or at least close to 2, right? So the answer here is 2, all right? Basically, if you want to boil it down to some sort of slogan, I'm not big on, cutesy little slogans in mathematics. I think it's always better to actually, understand what you're talking about rather than memorizing some sort of cutesy thing. But one convenient way to think about this, typically, if you want to do actually f of whatever, you look at the point. So up here, f of -1, you actually look at this specific point and you choose the filled in dot or the empty dot, or if there's no dots like this, you just look at the curve, all right? Whereas if you are looking at the limit as x goes to somewhere of f of x, all right, for this one, you look along the curve, all right? That's what we did up here in the limit. Instead of looking straight up at this point, you look at the nearby points, which is to say you look along, as you go along the curve, where does the y values go? And in that case, the y values go to 2, positive 2, up here rather than down there. All right? It's only at this particular point that you get that value down there. All the other ones, though, get their values up here. All right, I hope that makes some kind of sense. Not really not a super, mysterious idea here. Okay. Sometimes the limits cannot exist. Let's try one like that. Okay, check this out. Sometimes the limit just straight up doesn't exist. How about here's a function. Looks like maybe like this. This is the function y equals 1 over x, right? It has a weird looking graph like that. What is limit as x goes to 0 of this function here, f of x? What is it? Well, that means, okay, you try to look at x equals 0. Actually, there is no value of this function at x equals 0. So actually, you can say f of 0 straight up does not exist, right? There is no such thing as f of 0 because when x is 0, there is no y value along this where this x value is, because these are asymptotically approaching, but they never actually reach the y-axis. Okay, but what about this? So as the x approaches 0, that means when I look at the nearby points, what do they actually what do the y values actually approach? And the answer is, again, there is no y value that these curves actually are approaching, all right? In fact, this one is like going down, you could say, to negative infinity. This one's going up to positive infinity. They definitely are not actually approaching any coherent value when you get close to x equals 0. So, also, the limit as x goes to 0, f of x, does not exist, all right? That's because there is no y value that the curve is not, there's a double negative there. It's because the curve isn't approaching anything. By which I mean, it's not approaching any specific y value. All right, you might say the curve is approaching infinity from this way and negative infinity from this way, but whatever, infinity doesn't count as an actual y value, right? That's what this answer should be. If it's going to exist, it's a number, okay? And infinity is not a number. I hope your parents told you that. Infinity is not a number. It is a thing, it's just not a number. Okay, so the curve isn't approaching any specific y value. That's why you say the limit does not exist. All right. This can also happen in this one. The curve is sort of going out to infinity or whatever. It can happen even if that's not the case. So here's another example where the limit of something or other does not exist. Something like if I have, one of these guys, right? So here's 1, 2 right there. What is the limit as x approaches 2 of f of x this time? Well, what do? You look along the curve and you ask yourself, what is the y value that this curve is approaching? Actually, there's kind of two different parts of the curve, and those two parts approach two different values, right? This side, the values are approaching the y equals 1, in this curve, whereas this curve, the values are approaching y equals 2. In any case, in that situation, you say the limit does not exist. That's because the curve is not approaching any single y value. In a sense, you could say the curve is approaching both of these values. We just don't want to get into that. So we just say, if you ask me about the limit, I say the limit does not exist, all right? Actually, maybe we do want to get into that. There's a more specific thing that you can say here. There is such a thing as, these are sometimes referred to as the one-sided limits. The limit, and it is true that there is sort of a limit if you only look on this side. The limit would be 1, right? It approaches 1. And there's a limit if you only look on this side. And the way we write those is this. So the limit as x approaches 2 with a little plus here. This means the limit as x approaches 2 from the right. The plus meaning this side, because this is the positive side and this is the negative side of the graph, all right? This is the limit as x approaches, this is how you read this, approaches 2 from the right. It means you look along the curve, but from this direction. You don't care about this side. You look on the curve from this side. And what do you get? You get this y value, which is 2. All right? And this is different from the curve from the left. So the limit as x approaches 2 from the left, that's what this minus means, would be 1. All right? So if I ask you the limit overall, there is no limit overall because it's sort of two different things here. But if you want to be more specific, you can say the limit from the right is 2, limit from the left is 1. All right?